Hi, today we're going to go through a PAT paper from 2012 looking at question 11. So question 11 asks us to solve minus 1 over x plus 2x less 1. Okay, well, what we want to do is our first thought should be to get rid of this x on the bottom here. We can't do much with that. So we'll multiply through by x to remove it from the denominator. However, what we've got to remember is that we don't actually know if x is positive or negative. So clearly we can't times through by x, because otherwise we won't know if we're going to swap these signs around, because a negative value will reverse the sign. So what we do is we times through by something that we know is always positive, and that's going to be x squared. So you multiply both sides by x squared. So doing that, we get, well, minus 1 times x squared is minus x squared. And that's less than, well, minus 1 over x times x squared is minus x. 2x times x squared gives you 2x cubed. And that is less than 1 times x squared, x squared. Okay, now we add x squared to everything to give us 0 is less than, well, 2x cubed plus x squared minus x less than 2x squared. Right, so let's sketch that down here. So, well, 2x squared is going to look something like this. It's going to be a bit steeper than our normal x squared curve, but it's still going to flatten out at 0 and like that. So how do we sketch 2x cubed plus x squared minus x? Well, we're going to have to factorize it. So we know that 2x cubed plus x squared minus x, well, we can take clearly an x out of that to give us 2x squared plus x minus 1. And that is equal to, well, 2x minus 1, x plus 1. So when is that 0? Well, that implies x is 0, a half, or minus 1. So let's mark that one. So we have minus 1 here, 0 here, and a half here. So what we're going to have is the curve coming up, like a cubic, down through 0, and then back up through a half. So we want to think about now our inequality here. So clearly we're concerned with the region where x squared, 2x squared is greater than 2x cubed plus x squared minus x. Let's label on the names of our graphs so we can clearly see it. So that's y equals x squared, and this is y equals 2x cubed plus x squared minus x. And that's if we label x and y. So, well, clearly we see a region here. So above, we want to consider only above the x-axis, otherwise it's less than 0. And well, we have x squared here, and we see it for this region here, our curve is less than x squared. Our 2x cubed curve is less than our 2x squared term. So we're concerned with this region here. And we're also concerned, we see, with this region here, ignoring this section because this is less than 0. So we want to find these values here. So how do we find the intersections? Well, clearly we're going to set them equal to each other. So we're going to let 2x squared equal to 2x cubed plus x squared minus x. So this implies 2x cubed minus x squared minus x equals 0. So bringing out the x, we get 2x squared minus x minus 1 equals 0. Or 2x plus 1 x minus 1 equals 0. So we see x equals 0 minus a half or 1. Well, we can clearly put that on our graph now. So this is going to be equal to minus 1 half, and this is going to be 1. Well, we know that our 0 is at a half, 0, and minus 1. So now I can simply read off our inequalities. So for this section here, we clearly see that we want x to be, well, less than minus a half and greater than minus 1. And here, we want x to be greater than a half and less than our intersection point 1. Put down clearly 1. So this here is our allowed values of x.